Hi everyone, in this video we will discuss Venn diagram chapter for CUET PG MBA. Now let us first discuss the basics of Venn diagram. So what is Venn diagram? So Venn diagram is another way to represent sets. Right? So this is closely related with set theory. So we can say that Venn diagram is nothing but a way to represent sets. So for example, let's say we have two sets. One is for English speakers and another is for Hindi speakers, right? So what we will do is we will denote each one of them with circles. So let's say English speakers is denoted by purple circle and this one is for black circle. Now one thing to notice here is, can there be some speakers who speak both the languages? Obviously they can be, right? A speaker or is a person who speaks English, obviously he can also speak Hindi if he knows the language. Similarly, a Hindi speaker can know English language as well, right? So what we will do is, we will represent these both circles. So this black one is for Hindi. So this is Hindi. Let's say I call this H, and this purple one is for English. Now since there are some speakers who are common in both, so we will create an overlap, right? So this common area will be H. Okay, this one is for E, right? So Hindi and English. So this will be common of both. So we will denote this by H intersection E. This is known as intersection. It means that the people who are common in both the sets. Okay. So this is one notation, intersection. One more notation is that how many total persons are there. So that would be union, H union E. So for example, let's say Hindi speakers are 50. Oh, let me write this in another way. Let's say we have Hindi and English speakers. Let's say there are 30 persons who speak only Hindi and there are 20 persons who speak only English, but there are 10 persons who speak both Hindi and English. So how many total persons are there? So there are 30 plus 10 plus 20, that would be 60 persons are total, right? So that would be your H union E. So this would be 60. And how many people are common in both? So there would be 10, right? So H intersection E is 10, H union E is equal to 60. And now how can we relate them all? So there is a formula H, or let's say let us generalize. So let's say there are two sets A and B. So what would be A union B? A union B would be A plus B minus A intersection B. Why are we subtracting this portion? Because let's say this is A, right? So when we took A, B already included this portion. Now when we added B, B again included this portion, right? When we added B, B again added this portion. So B included this portion A intersection B1, this portion A intersection B 2 times, right? So that's why we will have to subtract this one time. Subtract one time. Okay. So for example, let's say there are 70 people in set A and there are 80 people in set B. A and B. A is 70, B is 80. Okay. And let's say we are known with A union B and total persons are A union B is, let's say, 130. So if someone asks you what are the people who are common in both, so what is the A intersection B? So what you will do, you will plug all the values here. So 130 A union B equal to A 70 B 80 minus A intersection B, and we have to find this, right? So A intersection B would be 70 plus 80, 150 minus 130, 20. So 20 people are there who are common in both. Okay. So that's how we will do. And let us extend this to 3 sets as well. What happens if there are 3 sets? So let's say A, let's say B, and let's say C. Now suppose someone asks you what are the total number of people. So A union B union C. So how will you find? So let us first denote. So this portion will be known as A intersection B. And for A and C, what will be the common? This portion, right? So this portion will be known as A intersection C. And for B and C, this portion, right? So B intersection C. Now one portion is also there which is common in all three. This portion, this. So this would be known as A intersection B intersection C. Okay. Now for A union B union C, let us add them all. So A plus B plus C. Now we will subtract the common areas. So we will subtract these portions, these common ones. So minus of A intersection B minus of A intersection C minus of B intersection C, right? But while subtracting, what we have done is we have subtracted this portion how many times? In A intersection B, we subtracted this one time, right? So this is one time. For A intersection C, this portion, we again subtracted this, right? And for B intersection C is B and C is here, so B subtracted. In this portion, we again subtracted this, right? So we again subtracted this. So whatever times A intersects this common area, A intersection B intersection C was there, we subtracted all of them, right? So while when we added A, in A this portion was also there, so here it was also one time, here it was also one time, and here it was also one time. But we again subtracted them, all of them. So obviously we will have to add them one more time, right? So A intersection B intersection C will be added. So the total formula becomes, for three sets, union becomes A union B union C becomes A plus B plus C minus of all the two commons. Okay, two sets common, you can subtract them all. B intersection C plus C A intersection C. We have subtracted them all, and at last we will add A intersection B intersection C. Three sets common. Okay, this is three sets. These all are two sets. So we have to subtract them, right? And why we are adding this three set one? Because we subtracted them actually. Because for A, B, C, we added them three times. But while subtracting two sets common, we subtracted them all of those three times. So in totality, we can say that till here there is this portion being neglected. So obviously we'll have to add this portion one time. Okay, that's why this is added one. Now you can extend this to as many number of sets you want, but in exam they are not going to ask you more than three sets. Okay, they will never ask you a question on four sets, because that would be very hard one, because there will be lots of variables and lots of common sets will be there. So there is no point of asking four sets questions. So they will ask you two set or three set, and three set. So I hope these things are clear to you. Now we can solve questions. So the first question, in an examination 65% of students passed in mathematics, 48% passed in physics, and 30% passed in both. How much percentage of students failed in both the subjects? Okay. So let's say this is total number of students. Okay, this is universal set. We call this universal sets. And what is this? All students. All students who have sat in this exam. Okay. In exam. All the students who have sat in this exam. 65% of a student pass in mathematics. Let's say this is M. So this is 65%. This is 65%. 48% passed in physics. This is for physics, 48%, and 30% in both. This portion, 30%, right? How much percent of students failed in both the subjects? Now, what is the failed portion? So these are for past ones, right? So all the outside will be failed ones. All these, this outer area is failed one. Okay, so this is for failed in both. Now tell me how much percentage will be all students. So obviously this is 100%, right? Total students will be always 100%. And for M we have 65%, for P we have 48%, and for M intersection P we have 30%. So what is the union? What is the total number of students who have passed in at least one subject in maths or physics? So that would be M union P. So M union P is nothing but, you know, M plus P minus M intersection P, right? We subtract common one. So M is 65, P is 48, and common one is 30. So 65 plus 48, that would be 113 minus 30, that would be 83. So 83% is passed in at least one of these subjects. So how many percentage of students failed in both subjects? So remaining the students, right? So 100% minus this portion, minus 83%. So that would be 17%. So this outer area is 17%. Okay. And these two combined one is 83%. So that's why if we add them, 83 plus 17%, so we will get 100% of our students, this total universal set. I hope you understood the concept here. In two sets, this is very common. In a class, 60% of students pass in Hindi, 45% in Sanskrit. If 25% of them pass in both the subjects, 5% of students failed in both subjects. Again, the same question. We have 60 Hindi, 45 Sanskrit, 45 60, and 25 common. Pass both the subjects. So for universal set, if I exclude these two circles, so all these outer areas fail both subjects, right? All these outer areas. So this would be 100% obviously, all number of students. This is 60, this is 45, this is 25. So what is the H union S? That would be 60 plus 45 minus 25, because we use H plus S minus H intersection S. So 60 plus 45, 60 plus 45 minus 25, right? So 105 minus 25, that would be 80%. So 80% is either passed in Hindi or Sanskrit. So at least they have passed in one subject. So how many have failed in both the subjects? Obviously we will have to subtract this portion minus 100%. So 100% minus 80%, that would be 20%. Option third. Okay. So I hope you understood. Both of these questions were almost similar. Okay, third question. In an examination, 80% of boys passed in English, 85% in maths, while 75% in both. If 45% boy failed in, if 45 boys failed in both, the number of boys who sat for the examination. So same approach, English, math, and this is English intersection math, common one. 80%, 85%, and this is 75%. And they have asked you number of boys who sat for the examination, total number of boys. So there are some boys who have failed in both the subjects. Those are these outer ones. Okay. So obviously overall would be 100%. This all the students would be 100%. Let us find E union M. How many students passed in at least one subject? So E plus M minus E intersection M. Plug in the values, 80, 85 minus common one, 75. 165 minus 75, that would be 90%, right? So 90% is at least E or M. So if you combine these two circles, then you will get 90%. So obviously remaining one would be 10%, right? So 10% is failed in both. 10% failed in both. Failed in both. And that value is given as 45. So tell me, 10% value is 45, and you have to find 100%. So obviously we will multiply by 10, right? So 450. So total number of students were 450. Option B, second option, 450. I hope you understood the solutions. Now these two questions, I think there are two questions which you have to do yourself. So question number 4, in an examination 34% failed in mathematics, 42% failed in English, 20% failed in both subjects. The percent of students who passed in both subjects. Again, very easy one, similar approach. Okay, so this is your homework, and once you solve the question, let me know in the comment section. So please put your answer in comment section. Again, same homework. Again, post your answer in comment section. So you can post your answer for both the question. You can write like question number 4 answer is this, your answer. Question number 5 is answer is this. Okay? So this will be a good exercise for you. Okay, let us discuss some previous year questions. So this is from 2022 paper, and this question was actually dropped. And why was this dropped? Because none of the options matched with the answer. Okay, so the answer is for this one is answer 150. If you can see, none of the options match with 150. And in next question we have 85 as answer. Again, none of the options match. So that's why they dropped the question. But let us solve this question. So this question is on, in a housing society, 50 households subscribe to newspaper 1, 60 to newspaper 2, 70 to third. Further, 25 households subscribe to both 1 and 2, 20 to both 2 and 3, and 10 households for both 1 and 3. Also, there are 5 households which subscribe to all 3 newspapers. Now, this question is asked, if 20 households do not subscribe to any of these 3 mentioned newspapers, then what is the total number of households in the newspaper? Okay, so this is 3 set question, right? There are 3 newspapers, so there are 3 sets. These are 3 newspapers, and there will be a universal set. Okay, because there will be some person who are outside this, who have not subscribed to any newspaper. So this is universal set. And what is the universal set? All the number of households in the society. Universal set is number of households in society, which they have asked, right? Then what is the number of total households in society? Okay, so this is, let's say this is first newspaper, second, third. So this is 50. First one is 50. Second is 60. Third is 70. And 3 common ones are 25, 20 and 10. And there are 5 who are this common one. This is the common one, right? In all 3. So this is 5. Okay, so we will use union, right? We will first have to find how many households are there which have subscribed to at least one newspaper. So that would be 1 union 2 union 3. Okay, 1 is the number of households which have subscribed to newspaper 1. Similarly for newspaper 2, newspaper 3. So what will be the, how we will solve this? So 1 plus 2 plus 3 minus 1 intersection 2 minus 1 intersection 3 minus 2 intersection 3 and plus 1 intersection 2 intersection 3. So this formula is for 3 sets, right? You don't have to memorize this. You can think logically that first we will take 1 set, so we will add them, and in second we will take 2 sets common, we will take pair of 2, and that we will subtract, and at last we will also add, right? So these things go in, these signs go in alternate fashion, right? So this is addition, these 3 are for subtraction, and this is for again addition. Okay, so you can think of it like this: 1 set plus sign minus 2 sets common, and again plus 3 sets common. Okay, plus minus plus alternate signs. So what is the number of households for first newspaper? 50, right? For second 60 and third 70. So 50 plus 60 plus 70, 50 plus 60 plus 70. So these are for single sets. This is this value, okay? For 2 sets common, we have 25, 20 and 10. 25, 20 and 10. And for 3 sets common, I think we have 5. There are 5 households, okay? This is 5. I can simply solve this. So if you add this, then you will get 1. This was 30 or 70. This was 70. Okay. This is 70. So 50 plus 60, 110, 70, 180. This is 30 plus 25, 55, and this is 5. So 180 minus 55 plus 5. So that would be 185 minus 55, that would be 130. Okay. So 130 households are there which subscribe to at least one newspaper, either 1 or 2 or 3. But what they have asked, if 20 households do not subscribe to any of the 3 mentioned newspapers, so these 20 households are the outer ones. Okay, they don't belong to any newspaper. So we found that there are 130 households which have at least one newspaper, and there are 20 which have do not any newspaper. So how many total households? So 130 plus 20, that would be 150, right? So this is your answer. Answer is 150, which is not mentioned in any of the options. That's why they dropped the question last year. So the answer is 150. Let's move on to the next question. Same data is there. What is the number of households that subscribe to only one newspaper? So how will you find only one newspaper? Only one newspaper. Okay. So what they're asking is, they're asking for this portion. They're asking this portion, this one newspaper only, this portion, and this portion, because these are the households which have only one newspaper, right? They have no common portion with others. So how can we find? We know all these values now, right? So let us draw again these 3. So we have 50 for all, but let's not fill that one first. Let's say we have 5 this portion. Let's say this is 1, this is 2 and 3. What is the common between 1 and 2? 1 and 2. 1 and 2 are how many households? 25. So from 25, 5 is gone. So this would be 20, right? And total are 50. So 25 is gone. So this would be 25. Okay, no, wait. There is one more portion, right? So let us calculate this at last. This portion will be also there. Now let's move on to 2 and 3. So 2 and 3, we have 20 households. So these two we have 20 households. From 5 is already gone. So this would be 50. 1 and 3. 1 and 3. For 1 and 3 we have 10 households common. But this 5 is already gone. Right? In this portion 5 is already gone. So this would be 5. Now you can fill all the values. So for this 50 is total for first newspaper, but 20, 25 and 5, 30 is already gone. So this would be 20, right? For 2, this is 25 plus 15, 40 is gone, and 60 households are there. So this would be 20. Similarly for third we have 70 households. But how many are gone? 15 plus 5, 20 plus 25. So 25 is gone from 70. So that would be 45. Now you can add them all. These are the households which are single, because they are not overlapping with anyone, right? So 20 plus 20 plus 45, 85 is your answer. And again, which is not mentioned in any options. That's why this question was dropped. If you look at the answer key of last year, this question was removed. Okay, let's move on to the next question. This is again from 2022 paper. In a school, we have 250 students, and every student play at least one of the 3 indoor games of chess, carom, or sudoku. So again, there are 3 sets: chess, number of students who play chess, number of students who play carom, number of students who play sudoku. 110, 90, and 100 play chess, carom, and sudoku respectively. So chess is played by 110, carom is by 90, sudoku is by 100 students. 20 students play chess and carom, 20 students play carom and sudoku, and 25 students play chess and sudoku. Okay. So what they have given is, let's say this is chess, so CH, I am denoting this by CH. This is for carom CA, and this is for sudoku SC. They have given This whole chess is 110. This whole carom is 90, and this Sudoku, this portion whole, that is 100. They have given for 20 for chess and carom. So this portion they have given this for 20, and 20 for carom and Sudoku, these two, and 25 for chess and Sudoku. What they've asked is number of students to play all three games. So they are asking this portion, this common one, which is common in all three. Okay, this common one. So again, we can use the formula. Let's say CH union CA union Sudoku. These will be the students who are total students. Why? Because see, read this line. In a school there are 250 students, and every students play at least one of the three games. So this every students have to belong to one of these three sets, right? So it means that this only is the inverse set. Okay, there is no students which is outside of these three sets. So this means that this value is equal to 250, and we know this formula, right? We know that CH plus CA plus SU minus intersection of all these three, CH intersection carom plus carom intersection Sudoku plus Sudoku intersection chess. All these three will be subtracted, and at last we will add the common one, CH intersection CA intersection Sudoku. So at last we will add the sets, the people who are common in all three sets. Okay. So now you can plug all the values. CH is what? CH is 110. So 110. Okay, I think we will have to go to the next page. 110 plus carom is by 90, Sudoku is by 100. Carom is 90, Sudoku is 100, minus, not two sets common, 20, 20, 25. 20, 20, 25. Now three sets common, that would be added. Now we want to find this value, right? So let's say this is x, and this whole value is 250. We know that. So you can solve this now. So this is 250 equal to, this value would be 300 minus 40 plus 65 plus x. So from here you can get x equal to 250 plus 65, 315 minus 300 equal to 15. So there are 15 students who are common in all three. So they play all three games. Okay. So that would be option A. So again, there is not much calculation actually. I have written this. You may think that this is long, but once you plug in the values directly, then this would not be hard. You don't have to write all these things. That's what I'm saying. You can simply write the value. You can simply do this step. Okay. Next question: the number of students who play only chess. So in the same question, we have to find how many students are there who play only chess. It means that we want this portion, this, not these portions will be removed. Okay. So from chess, we want only this portion. So we don't want this portion, and this portion. Why? Because there are common with other sets as well. So how can we find it? Now we know maximum data now. This portion is 15. Let me draw again. Okay, here we can do chess, carom, Sudoku. Now we know that this portion, all three common one, this is 15, right? We found 15. So this is 15. This portion. Now this portion we know that chess and carom. What is the common between chess and carom? Chess and carom 20. Chess and carom 20. So if this whole is 20 and 15 is already gone, so this would be 5, right? Now one more thing, chess and Sudoku common. Chess and Sudoku. So chess and Sudoku is 25, right? So 25 is chess and Sudoku. Now from 25, 15 is already gone. This portion 15 is already gone. So this would be 10. So 10, 15 and 5. 10, 15 and 5 is gone from chess. From 110, right? Chess is 110. So if you subtract from 110, then you will get. So 110 minus 15 plus 15, 30. So 110 minus 30, that would be 80. 80 students are there who play only chess. Okay. So option, I think, let me see the option. 80 is C option. So this was also an easy question. If you are comfortable with 3 sets, and that is not a hard thing to do, you can always practice. Okay, so I think all the questions are done. There are 2 homework questions as well, so please solve them and put it in the comment section. We can have a discussion there. Also, if you have any doubt, you can always ask in the comment section. I will try to answer them all. Okay, let's meet in some other videos. We will discuss more such chapters. So thank you again.